So there are 5 rules, and I'm going to refer to them as the big 5. That's often how we refer to them. So if you ever hear someone talking about the big 5, they mean these 5 rules for proving that triangles are congruent. They're all 3 or 2-letter abbreviations. So remember in proofs how I don't want you guys to abbreviate too much. These are the ones that you can. So I gave you that piece of paper with all the different reasons for proofs. I gave it to you a couple classes ago. These are the ones that you guys can abbreviate using 3 or 2 letters depending on the name. So we're going to be learning the side, side, side rule, the side, angle, side rule, and the angle, side, angle rule today. The others are angle, angle, side, and HL, or hypotenuse, leg. So there are 5 total, and yes, you do need to have them memorized to know how to use them. But the more you practice them, the more they'll kind of just sink in, and you'll be able to use them fluently. So when we were talking about congruency last time, we were talking about all the sides and all the angles have to be congruent, which is true, right? For shapes to be congruent, you want to have all those things happening. But to determine if a shape is congruent, you don't need to know all those things. These are shortcuts. These are the least amount of information that you would need to know in order to determine whether triangles are congruent or not. So our first one's called the side, side, side rule, or postulate. It says that 2 triangles are congruent to each other if all of their corresponding Oops. I don't want to go back to page, I'm going to stay here. All their corresponding sides are congruent. So 2 triangles are completely congruent to each other if all their corresponding sides are congruent. This doesn't mention angles at all. Right? We do know that congruent shapes are going to have congruent angles, but for this rule, all you need to know is that the sides are congruent, and then you can conclude that the angles are congruent later. So for example, this picture, I have the single mark side right here. I have a corresponding side that's congruent to that in the other triangle. So that's one set of congruent sides. I have the double mark, which is over here. So that's 2 sets of congruent sides. And then the third one right here with the triple mark, those are also congruent. So if you guys have 3 sets of congruent sides, then you know that the full triangles are congruent. That's all it really is. Now this one's slightly different. See how we have single, double, triple? Do I have that in this triangle? Or sets of triangles? I see the single and I see the double. Where's the triple? Do they have a third side that's congruent? Where? Okay. We've talked about this. I don't remember if we talked about it in extreme detail last time, but the reflexive property. Did we talk about that last time? When you're overlapping, when triangles are sharing a side, if you were to separate those triangles, wouldn't they have FD? Each of them would have a copy of FD if you separated them. But right now they're on top of each other. It's like coinciding lines. When we talked about parallel, intersecting, perpendicular. They're coinciding, so they're right on top of each other. So that's why you can't see 2 copies. You only see the one because they're on top of each other. But you have to know that there are 2 representatives. If you were to separate them, you'd see it, but you can't right now because they're together. So you have to say FD is equal to itself. So they're really 2 copies, they're just on top of each other. So that's why we would say that these triangles are congruent by side, 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 because they still have 3 congruent sides. Okay? Because they're overlapping right on top of each other and they're coinciding, we can say that it's equal to itself. So we use that a lot, so I want you guys to write this down, the reflexive. We use this property often in this unit. So make sure you remember that reflexive is there, and it's something that we're going to use a lot. Okay? Alright, the next one is called the side angle side postulate, and the way that the letters are arranged is very important. So this rule says that 2 triangles are congruent to each other if 2 sides and the included angle of one triangle. So that means it's a sandwich. You have 2 sides and then the angle in between. That's what included means. It's in between the 2 sides. Those are congruent to the corresponding corresponding 2 sides and the included angle of the second triangle. I like to refer to them as sandwiches. So you're going to have a side sandwich, which means the bread, the 2 slices of bread are the sides, and then the whatever's in your sandwich is the angle. So in these triangles, I have 2 sides right here. in the triangles. These two sides are congruent to each other. That's the side and the side. The angle is in between the two sides. That's the angle in the middle. So if you have that pattern in both triangles, you have two pairs of congruent sides and an angle in between. That's the side angle side rule. You don't need to know the third side. You don't need to know the other two angles. This is the least amount of information you need to know for the side angle side. Okay? What about this picture? Is there anything I can do to help that rule kind of show up a little bit more? Is there a property I might be able to use in this one? This triangle compared to this one. How many pairs of sides do I have right now that are congruent? 2 pairs. I have 1 pair. How many do I need? Where's the second set of congruent sides? Reflexive. Remember, that shows up all the time. You guys need to be able to see it. If the two angles are right up against each other and they're sharing a side, this side is equal to itself. Because if you were to split them apart, you'd see it twice. But right now, they're just coinciding. So you would say that this is another set of congruent sides. Now, a lot of my students like to do this strategy. You don't have to, but a lot of my students like to use a visual where they label what they have in each triangle. So like for this one, I have a side, and then an angle, and then a side, with the angle in between. And in this triangle, I have the same thing. I have a side, and an angle, and then that side. So if you like to label them with S's and A's to see what the pattern is, you just want to make sure that they're corresponding and congruent, and they're in the correct pattern for the rule. And those would also be congruent. Alright, everybody okay with that one so far? Side sandwich. We're going to do the exact same thing, but we're going to switch it to an angle sandwich. So you have 2 angles and then the side in between them. So it's kind of like this one, but we're switching the dynamic. So this one is going to say 2 triangles are congruent to each other if 2 angles and the included side. So we're just changing the pieces of the triangle that we're looking at. So 2 angles and then the included side of one triangle are congruent to the corresponding two angles and the included side of the second triangle. So it's the same idea. You want to make sure you have 2 congruent angles in both triangles that need to be corresponding, and then the side in between them is also corresponding and congruent. So if I look at this picture, I only see 1 set of congruent angles, and I have my side. Where's the other angle pair? The vertical angles. You'll notice that in a lot of these pictures, they're not going to give you all the information you need up front. It's very rare that they're going to do that. So you may have to look for ways to add information using valid methods only, and then you can get it to show up. You guys see how I have angle, side, angle in both? Everything's corresponding and congruent, and you have that angle, side, angle pattern. So these triangles would be congruent to each other. I don't need to know the other 2 sides. I don't need to know the other angle. This is the least amount of information I need for this rule. Okay? What about this triangle? I have angle, side, angle, but then I have only angle, side. Can I fill in more information here? How? Linear pair. So I can add this right here using the linear pair postulate, right? If I see that I have a linear pair, I can take whatever I have, subtract from 180, so that gives me another 90 right here. So now do I have angle, side, angle in both triangles? Yeah. You need to have that pattern in both triangles, and they need to be corresponding. So let me draw an example for you guys. You don't have to draw this if you don't want to. This is a non-example. Oops. Well, okay. What if I had that? Well, which is a horrible example. There. Imagine I have this. I have this thing. These 2 angles are congruent. These are vertical. And then I have those 2 sides. Would this be angle, side, angle? They both have 2 angles and a side. Can anybody explain why this would not be angle, side, angle? Yeah. Yeah, the side in this triangle is not in between these 2 angles like it is over here. These 2 sides are not even corresponding. Alright, so corresponding is a big part of this. The sides and angles that are congruent need to be corresponding. So if you notice that they're not matching up correctly, then that means that they're not going to be congruent. You can't use any of our rules here to say that they're congruent because they're not matching the pattern. They need to be corresponding in the same pattern in both triangles. So make sure you're really, really careful. They could also do something like this. They could give you the same sides, but are they equal to each other? No, this one's a double mark, this is a single mark. So there are little things they can use to try to trick you. So you need to make sure you're paying very close attention to the markings and how they're lined up in the diagram. So those are the 3 rules we're going to practice today. We're going to be using side, 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 and angle, side, angle to determine if triangles are congruent. So if you turn the page, you have a bunch of examples. Now, like I said before, they don't always give you all the information that you need to start. There are only 4 ways that you can add information. Only 4. The biggest issue that I have with this when I teach this originally to my students is that they just want to add information wherever they want to. They want the triangles to be congruent so bad that they just randomly add information to force them to be congruent. But you can't do that, right? The only ways that you can add information are if you see vertical angles. It means that they're congruent. If you see parallel lines, it means you're going to have congruent angles somewhere too. Most often, you're going to be using alternate interior angles with that Z trick. Sometimes you use corresponding, but most often it's going to be alternate interior. Your lines need to be very clearly indicated that they are parallel. You may not assume that they are. So only when you see the little triangle. So vertical angles, parallel lines. If they share a side or an angle, that's a reflexive property that we've seen already. Or if you guys see an isosceles triangle. That theorem we learned before, that if you have congruent angles, you have congruent sides and vice versa. These are the only 4 ways that you can add information. Also, never assume that angles are right angles. So if you see that they're kind of intersecting and they look like a right angle, but you don't have a little box, you cannot assume that they are 90. It's very dangerous. Okay? So no assumptions, and you can only use these 4 methods. So let's go ahead and start looking at these. We're going to add any information that we can, and then analyze the information that we have to decide if they're congruent or not, and why. So for this picture, before you make any conclusions, is there anything I can add? Go through those 4 reasons. Are there any vertical angles in this picture? Okay, so I can say these are vertical. Is that enough, or do I need more? Does this look like any of the rules that we learned? Which one? I have angle, side, angle. Do I have that same pattern in the other triangle? Angle, side, angle. And they're all matching and corresponding. So these triangles would be congruent by the angle, side, angle rule. Okay. Can I add anything to this diagram? Are there any vertical angles? No. Parallel lines? No. Reflexive? Yes. They are right up against each other, so they're sharing that middle side. That's coinciding for both triangles, so it's congruent to itself. Is that enough to prove that these triangles are congruent? What do I have? I have side, angle, side. Do I have that in the other triangle? Side, angle, side. Yes, I do. So these are congruent by the side, angle, side rule. Right? This one, vertical. Vertical angles? No. Parallel lines? No. Reflexive? Yeah. They have that coinciding piece that they're right on top of each other, so they have that side in common. Is this enough to prove that the triangles are congruent? Using what rule? Side, side, side. Alright, what about this guy? Vertical? Do you have any parallel lines? Any reflexive? Any isosceles? Okay, so is this enough to prove that the triangles are congruent? No. So we're going to say no, we can't prove that they're congruent, and the reason why is not enough information. So that comes back here just like we did for parallel lines, right? But the question is going to ask you, can you prove that the lines are that the triangles are congruent? So you say, no, I can't prove that because I don't have enough information. Also, are these 2 sides that are congruent, are they even corresponding? No. See how this one's the hypotenuse, it's across in the right triangle, this is a leg? They're not even the corresponding sides. So even if I had enough information, they still wouldn't be congruent because the corresponding sides aren't matching up. So make sure you're careful with that too. Alright, over here, can I add any vertical angles? No. Do I have any parallel lines? Reflective? What about isosceles? So I can't add any information using those 4 methods, but they gave me this. Is that helpful in any way?
Yes.
What? How?
They are
What are?
Y and Z.
Y.
Because X is the midpoint and
So what 2 pieces are going to be congruent?
Y.
Y, Z?
Y, X and X, Z.
That's close. Let's be careful that we name them correctly. Look at how the shapes are outlined. YX is congruent to ZX. Alright? I want you guys to get used to naming them in the correct order like we learned on day 1. Because the second triangle has been reflected, the Y and the Z are corresponding. So when you name the sides, it should be YX and then ZX, because these are the corresponding sides and that's how they're arranged. Okay, so just remember, details are important in how you organize the letters. So is this enough to prove that the triangles are congruent? Yes or no?
Yes.
By which rule? Side, side, side. And it may not look, so another point I want to make on this, see how the left side of this triangle is congruent to the right side of this triangle? You may be worried that they're not corresponding, but if you look at how they've been reflected, you can tell that that's not an issue here. Right. Over here, I could tell they weren't corresponding because this is across from the right angle and this is not. But over here, you don't have to worry too much about the corresponding part because it's clearly been reflected. So just be really careful with that. And if it's vague, we'll have to give you the name of the triangle so you can tell which parts are corresponding. So don't be too worried about that. It'll be obvious if they're not corresponding. All right, what about this one? Vertical? No? Parallel? Reflexive?
Yeah.
Okay. Is that enough? What rule would that be? Nope, that's not side and side. Is the angle in between the 2 sides? That's how it's spelled. Side, angle, side needs to be a sandwich, but the angle in between, so this is not side, angle, side. This is actually angle, side, side, which is not a rule that works. Think about what it spells. We don't use that word, right? So angle, side, side, or side, side, angle, if you want to spell it the other way. That's not a rule that will work. That's an invalid rule, so you can't use that. So does this mean we're stuck? Is there nothing more we can add? This right now is not enough right now. But is there more that I can add to the picture? Yeah. Look at the big picture. I know we're comparing to see if this triangle is congruent to this triangle, but if you kind of merge them together and look at the big picture, what do you have? An isosceles triangle, right? So what do if I have an isosceles triangle, because I have these 2 congruent angles, what else do I have? These 2 congruent sides. So I can say that these are congruent to each other. I'm just going to write a note on how I know that. If my board will let me. Which it won't. But you can write isosceles triangle right there to remind yourself on how I got that, in case you go back to your notes and you're confused. So I use isosceles triangle to get this. Now do I have enough information? For sure. What's one way, because there are 2, what's one way that I could say that these 2 triangles are congruent? I can use side, 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 because all 3 sides are congruent. What's another one? Now I can use side, angle, side. I couldn't use side, angle, side before because I didn't have the sandwich going on. But once I add this side right here with the 3 marks, then I have a side sandwich with the angle. So you guys don't have to give me both. Just pick your favorite. Write it down. Okay? Any questions on that one? Sometimes you may need to add more than 1 marking. Again, just cycle through the 4 reasons on why you can add information and you'll be good to go. Alright, what about the next one? What information can I add? I see what? Okay, so there are parallel lines, right? Very clearly indicated by the little triangle. So what kind of angles do I have and what do I know about them? I have alternate interior. You guys can use that Z trick with the parallel lines. Like this. So what 2 angles would be congruent? Z or TZG, this one right here, and ZGP, that one right there. Or if I name it correctly, sorry, PGZ. So those 2 angles, the corner of the Z using your alternate interior, those are congruent. Is that the only information I can add? What else? Reflexive. Is that enough? What rule would that give me with that information? Side, angle, side. I have a side sandwich with the angle in between with both triangles. Side, angle, side, and side, angle, side. Does everybody see that? So these would be congruent by side, angle, side. Alright, what about the next one? What information can I add? Reflexive. Is that enough? What do I have? Angle, side, angle in the left-hand triangle, and then angle, side, angle in the right-hand triangle too. So if you have that pattern and they're all corresponding, you can use the angle, side, angle rule. There you go. Alright, so everybody see how we use those rules? We got information using the 4 methods if necessary, and then decide if they're congruent. Alright, this next type of question is very similar. They're kind of just going backwards. So for this one, they're saying that the shapes are for sure congruent, right? And they're even telling you which method they're congruent by, but they don't know what the third piece of information is in the diagram to make that happen. So sometimes they're going to give you a visual, sometimes they won't. So if they won't give you the visual, you guys need to make it for yourself. So in this one, just to kind of scaffold our way through, they've already given us a diagram here. We're trying to prove that they're congruent by side, angle, side. But what do I have in each triangle so far? I only have one side and one angle. Okay? So if you want to, you could label them using the letters like I was talking about before. So I have one side and one angle. What do I need for each triangle? Another side. But it's very important you know which one, because I have 2 options. To know what is the other side that I would need to complete the side, angle, side pattern. What side would I need in this one? I would need BA, this one right here. So let's go ahead and start with that one. BA. I know that to have the side, angle, side pattern in the one triangle, I need to have BA. But what should that be congruent to in the other triangle? BD?
ED.
Oh, ED. Yes, ED. Make sure you name it correctly. Since I named it BA in this triangle, starting with the marked angle and going down, you have to do the same thing over here. Start with the marked angle and go up. So ED. Alright, so it's just finishing the markings to get side, angle, side. So everybody see how I did that? Alright, these next 2 don't have a visual. So you want to create one for yourself. We're going to create the visual and then add these markings that they've described for us. So draw any arbitrary triangle that you want. Try to make them look as similar as possible. Just remember they're congruent. Now don't put the letters in automatically because we don't know exactly where they are yet. We're just going to put them in slowly as we add the markings. So I know that side AC, you get to pick whatever side you want to be AC. So I'm going to call this side right here AC. That's congruent to DF. So use the corresponding arrangement here. Just have them right up next to each other. A, C, D, F. Have them correspond the way that they're written. Does everybody understand what I've done so far? Use the first marking. I also know that AB, so the only point I have left is this one right here, so that must be B. And then this triangle, that must be B. So I know AB is congruent to DE. So this is our visual so far. This is our diagram. I'm trying to prove that these triangles are congruent by side, side, side. So what do I need? I need CB, so that's the third side in the left triangle. CB needs to be congruent to what? FB. And that's why you want to make sure you draw it very carefully using guidance from the other congruency statements that they've given you, so you know what points are corresponding, so you can name it correctly. So that's how you finish that one. Okay? I'm going to let you guys try that last one on your own. Draw the picture very carefully. Add the labels as you're adding the congruency markings, and then figure out what the last piece is to get angle, side, angle. You can arbitrarily pick wherever you want B and E to be. It doesn't matter. You set the stage. Alright, what do you guys think? What's the third congruency that I need? First of all, is it another side or another set of angles? It's another set of angles. So I already have one set of angles, I already have one side, I need the other set of angles. Which set of angles will help me get that sandwich pattern? C and F. So you should have had angle C is congruent to angle F. That gets you your angle sandwich and the triangles, and then you're good to go. So remember, you have to name and label the triangles very carefully based on these markings. So go slow and be careful. Alright, so that's the basic stuff. Alright, and I do want you guys to draw a picture for those if they're not provided. That will be something I'll be grading, just to make sure I understand that you know how to label and name the triangles correctly. So far, does anybody have questions on those kinds of problems? Okay. Now, these ones are honors specific. They look way more complicated than they actually are. There's a very easy strategy that you guys will be using in this process. So basically this is different because the triangles we're trying to determine if they're congruent or not, they're overlapping. They're on top of each other. So it's harder to see when they're on top of each other when you're trying to figure out what lines are corresponding to what and all of that. So the easy strategy you're going to use is just to redraw them separate from each other. Okay? In the question, they're going to tell you specifically what triangles to look at because there are so many different triangles that you can create. Right? You have the small ones, you have the bigger ones put together. So they're going to tell you which triangle specifically. So you would redraw them. That's why I have space in each box. Okay? You're going to redraw them separate from each other and then label or add any markings that they provided and then just look at them that way. So we're turning this complicated question into the ones that we saw on the previous page where they're separate from each other. Okay? So we're just going to follow the directive that they've given here. So I'm going to be looking at triangle ABC, which is right here. I'm going to try to draw it as best as I can to match the diagram, if my board will let me. Okay, so this is ABC, and you would just add the letters. So I have B here, A here, and C here. Right, so just drew ABC. And I'm going to be comparing that to DCB, which is this triangle right here in the diagram. Stop. And then again, once you draw the triangle, make sure you label it. So here's C, B, and D. So now the triangles have been separated. Make sure they're in the same orientation as they were previously. You don't want to try to flip them or reflect them. It'll make it too confusing. So just draw them as best as you can separate from each other. Now we're going to add these markings. I know that angle, right, the symbol for triangle and angle are very similar, so make sure you're careful. Angle ABC, which is right here, is congruent to angle DCB, which is right here. Alright, so add that marking. They're telling us that much. They're also telling us that angle ACB, which is right here, is congruent to DBC, which is right here. Alright, so that's what they provided for us. Now we have to add any information like we would have before, looking to see if there's vertical or parallel or anything like that. Is there any information I can add to these? Reflexive. If you look back at the diagram when they were together, weren't they sharing this bottom side right here? When you separate them, you can still tell that they're sharing that side because what do you notice about the letters? CB and then CB again. That's that coinciding side. It's been split. So if you have the exact same side, shouldn't it be equal to itself? So I'm going to go ahead and add a marking here. You can see the reflective when they're together. When you pull them apart, if you notice that you have the exact same letters, you know that they're congruent. Okay? So now is this enough to prove that they're congruent? What rule? Angle, side, angle. So I would say yes, they are congruent by angle, side, angle. That's how you approach these. You just draw them separate, figure out what's going on. You may need to add information the same way as before, and then you just decide if they're congruent or not. Okay? This one over here is talking about triangle ABC again, but it's been arranged slightly differently. So ABC looks like this, sort of. That's A, B, and C. We're comparing that. We are comparing that to DCB, like we were doing before, but again, it looks slightly different. And the information they provided for us is different this time. They're telling us that DC in this triangle is congruent to AB. We have that mark. We know that okay, so this is where it gets a little bit complicated. They're talking about DE and AE. Is DE and AE in these separated triangles? No. So sometimes you need to go back and forth. If they give you information about the diagram where they're put together, you're going to have to put that marking into this picture, and then we'll work with it in a second. So I see that DE is congruent to AE. We're going to go back up to this picture really quick. And then EB is congruent to EC. So I have to look at both of them together. Now, this is something that you guys need to remember back to Unit 1. Do you guys remember the segment addition postulate? You remember that? So if I'm looking at DB, that's the side right here, DB. What is DB made up of? DE and EB. All right. What about AC, which is the side right here, which is corresponding to DB? What is that made up of? AE and EC. You guys see how they've been chopped up into those little pieces? Well, if you guys look really carefully at the diagram, why did it change? Whatever. You know where this supposed to be. So DB is made up of a single mark and a double mark. AC is also made up of a single mark and a double mark. What does that mean about their full lengths? Shouldn't the full lengths be congruent if the two parts that you use to put them together are congruent? If you say that 2 plus 3 is something, shouldn't 3 plus 2 also be the same thing, right? You have the same kind of pieces, you're just adding them together. So what can I say about AC and DB? The full lengths. They're congruent. So that's something that they might do in these pictures where they're kind of overlapping. They may ask you to look at the diagram as a full picture and then add the little markings together to show that the full lengths are congruent. They may not automatically tell you the full length. You may have to add them together. So if you notice that the two sections are equal to the two sections, you know the full lengths are. So it's the segment addition postulate. Is there anything else I can add? They didn't give us any more information, but just looking at the picture. Is there anything else? Yeah, I see the segment CB twice. If it's the same line segment, shouldn't it be equal to itself in both triangles? So I can say that this segment is equal to itself, but in the other triangle. So is that enough to prove that the triangles are congruent? Yeah, by which rule? Side, side, side. Alright, you guys kind of see how we go through that process? Alright. I want to do one more with you guys and let you try to figure out the rest of them on your own. This one's a little bit different, so I'm going to do this one with you. So I'm comparing ABE, which is this kind of weird sliced one at the top. So we're going to redraw that. Now it looks like this. Yep. A, B, E. We're comparing that to ADC, which is the same kind of slice but going the other direction. Like this. So we still have A, B, and C. Alright, so redraw the triangles as best as you can, closest to the orientation as you can from the diagram. Then once you have them drawn and labeled, we're going to add the information we know. I know that AB is congruent to AC, so I can add that right off the bat. Pretty straightforward. I also know that AD is congruent to AE. So I have that so far. Is there anything else I can add from the diagram? Do I have a reflexive side like we did before?
No.
No, so I don't have like the CV repeating. I don't have that in this one. So I can't say another side is congruent. Does that mean this is no, not enough information? So when you guys looked up here in the name, you should notice you had CB twice, right? I had A, B, C, D, C, B. I had the letters C and B occur twice. That's why I knew that I had the repeating side. Over here, what do I have repeating in each name? Just one letter, A. What is that referring to in the name? Angle A. So if you notice when we were looking at the diagram where they're overlapping, they both had A in common. So reflexive applies to sides when they have a side in common. It also applies to angles if they have an angle in common. So reflexive works for both segments and angles. So if you look at the name and see something repeating, you know you have reflexive. So if you want to write that down for yourself, if you notice in the name of the triangles that there is a letter or multiple letters repeated, that means there's a reflexive property you're going to be using. It just depends. If it's one letter, it's an angle. If it's two letters, it's going to be a side somewhere. Okay, so using the information they provided and the reflexive angle, what do I know about these? Are they congruent triangles? What rule would I use? Side, angle, side. So yes, they are. Side, angle, side. All right, now the next three are a little bit tricky, but I want to give you guys an opportunity to wrestle with them for a second. So go ahead and work by yourself or with the person next to you. See if you can figure out these. Again, redraw, label, and then put the little congruencies in there and see what you can find out. So I'll give you guys a couple minutes to do that, then we'll regroup. Everybody managed to do the first one? Hopefully. Over side angle or angle side, however you spell it, it's not a goal. Can't use it, not enough information. I need to see, when you guys are doing the problems though, when you're redrawing the picture, I grade this. You being able to redraw the picture and add the information. So if you don't add the reflexive part, you have not given full credit. You need to add as much as you can into the diagram before you make your conclusion. So I've added everything that I can right now, and I still don't have enough information. So you need to make sure you add every little piece that you can from the picture. Now this one I can understand might be a little bit weird, so let's see. A, C, D kind of looks like this. And then the other one kind of looks like this. So B, C, D. What do you guys notice about the name? Told you this little trick, I had you guys write it down so you wouldn't forget. What does the name help you with? What do you notice in the name of the two triangles that we're working with? They both have C and D. So what does that imply? Reflexive. You can see it in the picture, but it's also in the name. So again, when you guys notice that they're overlapping and they're sharing a side, or you notice that they have two letters in common in their name, it means that they have that reflexive property, so you can add that right away. Then they also have other information that you need to add. You shouldn't be stuck. You have at least two things that you can add to the diagram based on these little diagram or little pieces right here. So this symbol means triangle. So in this diagram, it's a little bit interesting. They're telling you that two different triangles that you're not working with right now, those two different triangles are congruent to each other. Those two triangles are referring to our ABC, which is right here, and BAD, which is right here. They're saying those two triangles are congruent. Do those two triangles have anything to do with our triangles that we're looking at right now? What parts of the triangles that they've told us are congruent apply to these triangles that we're trying to see right now? Okay, so this triangle has AD. Doesn't my triangle I'm looking at right now also have AD? This other triangle that they're referring to had BC. Doesn't this triangle also have BC? Well, if they're saying that these two triangles are congruent, what do you know about AD and BC? They're congruent. If the full triangles are congruent, shouldn't all the little pieces be congruent? Yeah. So if they're saying that these triangles are congruent, then you can say that AD and BC are congruent. So part of those triangles. So in this diagram, you can say that these two sides are congruent based on that information. The full triangles are congruent, so those two sides that are relevant to our question right now are also congruent. Then they're also throwing into the mix that BCD, which is right here, is congruent to ADC, which is right here. So that's your side angle side. If you continue working with the congruent triangles, you can also see that AC is congruent to BD. So you could also say that these two sides are congruent to each other and do side, side, side. I had some students in my other class do that. So there are two different possibilities. You can continue working with the two congruent triangles to get more sides, or just throw that angle in. Okay? Either way. Now, did everybody get angle, side, angle for this one? And they're working through that? Or are we having some trouble with this one? Is everybody good, or should I work through that one? Okay. ABC is this one. And BAD is this one. Make sure you label everything. And then A. Alright, they're telling us that angle ABC is congruent to BAD. Those are angles, so I know that this is congruent to this right here. Right? ABC, BAD. Okay. Then they just tell us that triangle ABE is isosceles. What does that mean? What does isosceles mean? Two congruent sides. So triangle ABE is right here. So they're telling us that these two sides are equal. How does that give me more information? Right now I know that this triangle right here is isosceles. How does that give me more information? Anybody? What do you know about isosceles triangles? Angle. We can't use one letter to name angles because they're all sharing. If you have two congruent sides, what else do you have? Two congruent angles. When you guys see an isosceles triangle, that's the first thing you want to look for. We're not trying to solve, so the only application of isosceles is that you have angles and sides working together. So what two angles would be congruent if these two sides are congruent? You can't use one letter. If you have multiple segments coming from one vertex, you can't use one letter. EAB is congruent to ABE or EBA. Right. So if those two angles right there that are congruent, how does that translate down here? Oh, those angles that I just found translate down here. Now you can use one letter if you want to because they're not sharing anything. So what one letter angles would be congruent? Yeah. See how this angle right here is this angle when we redrew it? So I know that this is congruent. And then this angle is right here when I redrew it. So those angles are congruent because they have a isosceles triangle. Alright, I'm missing, this is not quite enough information right now. What else? Look at the picture, look at the name. You see A, the letters A and B twice. What does that mean? They're congruent. These two segments are the same segment, just in each triangle, so they must be equal to each other. So that's your angle setting. Alright, so I know they're a little bit complicated depending on what information they give you, but just redraw it, put information into this picture and this one to guide you through, and you should be able to get it. Alright? So you have a little bit of time left of class. I want to give you a little bit of time to work on the homework, but I also want to start our next graded assignment briefly, maybe like 5 minutes just to get a question or two done. So I'm going to go ahead and pass that out for you guys, just so you can get started, write the due date, and then put it away. So now, since you guys are shifted, we have different people responsible for these star desks. So let's go ahead and just get that identified. So if you guys have a little star on the corner of your desk, then you're responsible for passing out the folders for your group. For anybody who has not been a folder person yet, in the back row, you pass to your right. In the front row, you pass to your left. Right, to wrap them around the room, okay? They're not in the folders right now, but you can have them out because they're going to go into the folder. So I'm going to pass them out. You guys just take a copy, pass it down your row, and then do 2 questions. Pick your favorite 2, write your name, and then I'll tell you the due date in a second. So just do like 2 questions, and then we'll put it away. 1, 2. I'm going to make the due date for this one November 26th. Alright, so once you get your copy, write down the due date of November 26th. And then you can do 2 questions and then put it away.